Okay, good afternoon, everyone. Good afternoon also to our Professor Dr. Castillo report. So we'll have, Lord, thank you for the blessing that we thank you for the safe travel. Bless us, O Lord, as we Professor, bless our classmates. Bless us, O Lord, as we finish these doctoral subjects. Thank you for everything. This is all we ask for our Lord Jesus Christ. Amen. Okay, good afternoon once again. Of relations. So this is in connection with the report of Miss last time. So about relations. So we never escape our relations. So if we are going to have a review on relations, so this pertains to relations on a set. A relation on a set A is a relation from A to A. So in other words, a relation on a set A is a subset of A times A. So we take the example for a set A, let A 1, 2, 3, 4. Which ordered pairs are in the relation? Are ordered pair A, B such that A is less than B. So we have our illustrative solution. We have a relation one to an ordered pair and 3, 4. So we have a set of elements, one in the domain, and we have also our range. One is mapped to 2. We have also 2 is mapped to 3, then 2 is mapped to 4, and 2 and 3 is mapped to 4. So now let's come to discuss the properties or the kinds of relations. So we will now look at some useful ways to classify relations.
Those are not properties. Those are not properties but types. Those are types of relations.
Okay, sir. So types of relations.
Okay.
So for this topic in mathematics, so how we are going to determine our kind of relation. Is it reflexive, irreflexive? So we have also non-reflexive, symmetric, asymmetric, antisymmetric, and a transitive relation. So now we will talk about this relation, reflexive relation. So by definition, a relation R on a set A is called reflexive or is said to be a reflexive if an ordered pair A and A belongs to R for every element A belongs to set A. So as an illustrative example, so A arrows to itself. So in literal, R is reflexive if each element is related to itself or arrows to itself. And for this set of elements and a representation or a graphical representation, if we have a set of elements like this, a domain and a range containing two elements A, B, C, and D, A, B, and A, B, C, and D, which A map to A, we have also A map to C, B map to B, C map to C, D map to D, then D map to C, then D map to D. So this is called reflexive because an element of a set or an ordered pair is mapped to itself. We have A, we have B, we have B, C, then we have D, D. Unlike the other illustration here at the right side, so this is not reflexive because there is one of the element did not map to its self because the D and D. So if A and A map to A map to itself, then B map to B, C map to C, but there is one uh, element in a domain which is not mapped to itself, which is the D and D. So this is not reflexive. So we take the example set A 1, 2, 3.
So, supposed to be, balik ako to dito.
Sir.
Kailangan na ang AA, na ang BB, na ang CC,
Yes, sir.
na ang DD. Bahala pa na. What if na ang DD? Okay ra?
Yes, sir.
Okay, no?
Yes, sir.
For instance, we have AA, BB, CC, DD, and DB. Bahala pag na ang DB. Basta ang mga A to itself is always an element of the relation. Okay? Okay?
Yes, sir. So we take the example on a set A, 1, 2, 3, and 4 reflexive. So if we have a relation R1, so we have to denote that as R1, the first relation given. If we have a set, an ordered pair of 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, and 4, 4. So is it reflexive or not? So this is a reflexive because we can the relation R contains all the ordered pairs of the form AA or an ordered pair AA for every element A belongs to A that R has 1, 1, 2, 2, 2, 3, 3, and 4, 4. Okay, for this second relation R2, okay, we have 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, and 4, 4. Is this a reflexive relation? So this is not a reflexive relation. The pair 3, 3 is not in relation R2. But we have only 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. So we cannot find that ordered pair 3, 3. Then another one, we have relation R3, 1, 1, 2, 2, 3, 3. Is it a relation? No. So this is not a relation. So because 4, 4 is not there. Only we can have only 1, 1, 1, 2, 2, and 3, 3. 4, 4 is not here. Okay. So now we can we'll now go to a reflexive relation. A reflexive relation on a set A is called a reflexive if an ordered pair A and A is not belong to R. For every element A belongs to A, each element is not related to itself. So it's not related to itself. So this is an opposite of a reflexive relation. So the example given a while ago, so not a reflexive, so is this the example of this one. We take the example um, set A 1 2 3. If our R1 is 1 2 1 3 2 1 2 3, so this is irreflexive, or what we call not reflexive. 1 2 1 3 2 1, so this is irreflexive. Since an ordered pair A and A is not
Excuse me. Excuse me. Is irreflexive same to not reflexive?
yes sir.
Really? For example, R2 is not reflexive. Sakto? Di man siya reflexive.
Yes sir.
But it is not. I think
So,
not
R2
reflexive is different from irreflexive. Because irreflexive meaning, dili niya element ang tanang AA.
Yes sir, yes sir.
Sakto?
Yes sir.
So it is not not reflexive, is not the negate of.
This is not the opposite of.
Okay, continue.
Okay sir. So we have another relation, type of relation, the non-reflexive. So we have reflexive, irreflexive, and non-reflexive. So a relation R on a set A is called non-reflexive if an ordered pair A and A belong to R is true for some element A belongs to A and false for the others. So non-reflexive pala. So say for example, set A 1 2 3, is it reflexive, irreflexive, or non-reflexive? 2 2 2 3, so klaro na reflexive because all of the elements are related to itself. So R2 we have 1 2 2 2 2 3 3 1. So this is non-reflexive because 2 2 is an element of R2, but 1 1 is not element of R2. 3 3 is not element of R2 also.
That's
Then,
like that's
yes,
like
yes. Yes sir, yes sir.
non-reflexive is different from irreflexive, no?
Klaro. Okay, let's move to the next type of relation. Symmetric relation. So by definition, a relation R on a set A is called symmetric if whenever the ordered pair A and B, so nagpares na, uh, is an element of R.
Additional state follows.
B is element of R. Element is related to A. So consider the example set A 1 to 3. So we have R1 1 1 1 2 1 3 2 2 2 1, and the opposite of 1 2 we have 2 1 1 3 we have 3 1.
Okay.
is not a symmetric relation. So we have 1 2 1 3 2 1 2 3 and 3 3. So the there's if we have 1 2, of course na 2 1 1 3, so we cannot see her 1 3. So it does not arrows back to the elements A B to B A.
Ano siya, no?
Yes.
For 1 2 kinahanglan na ang 2
Yes
1.
sir.
If 1 3 kinahanglan na ang 3 1, but 3 1 is not there. So therefore it is
Yes,
not
sir.
symmetric, no?
So
3 3 wala problema. Ang
yes sir.
3 3 wala problema kay 3 3 if you commute that one, that is just 3 3.
Yes sir. Treaty
Okay.
yapon. Okay.
Okay, sige.
Let's move to asymmetric. Is called asymmetric if B A an ordered pair B E or A is not belong to R whenever A or an ordered pair A B belong to R. If A relate or a relation B, so B is not relate as B1.
Your slide please, your
we
slide.
have
Wala gamo bang slide nimo? Next
Yes,
slide
sir.
please.
asymmetric sir, asymmetric relation akong
No,
slide.
it is symmetric pa ni sa kuha diri. Ipakikuan no. Nag-change sa
Yes,
mga
sir.
klase.
Symmetric na nga. Yes, sir.
Mabuta sa daw.
Yes sir.
Dili gyud. Ngano man ni siya?
Sa signal na sir,
Symmetric pagyapon sa kuha.
sa signal
Sige na, what is symmetric? Asymmetric?
asymmetric if an ordered pair B A is not belong to R whenever A B or an ordered pair A B belong to R.
Oh, kini sinon siya. Asymmetric means not
Yes,
symmetric,
sir.
no? Pero katong
Yes sir.
ganito
So opposite siya sa symmetric ang asymmetric.
Yes.
Then we have R1 we have 1
Wala
1
gyud
2
change
1
ang imong
2 3
symmetric.
and sa signal sir. So we have R2 also. R2 is so
Wait na, kay walay kwan sa ko, walay. Wait sa wait.
okay sir.
Walay kwan sa ko, walay. Okay na, sige, go.
Okay.
A relation R on the set A is called
So
asymmetric
let's
if
move
B
to
of A.
if B
Okay, sige,
in order
continue.
for B A is not belong to R whenever A B. Yes sir. So the example, same example. So we have set A 1 2 3 asymmetric. Yes. The answer is C. Yeah. Same yan ang example. So
It asymmetric.
Yes, sir.
Wala ang 1
2 1. Yes sir.
2 3 wala ang 3.
Wala ang 3, 2.
Look at
Yes sir.
your kuan. Look at your key. So what's happening to R2. Dili man nimo i-test ang 2 ug 3 kay ang A is not equal to
So
B man.
R2 is
So is
not
that
is asymmetric pa rin, sir. So this is wrong. Asymmetric pa rin because
okay?
we don't have so 2, 2, 3,
You don't have to test 2, no, and 3 because that, but
Yes.
by definition A is not equal to B. Kinahanglan dili nimo apilon ang 2, 3, 4, and 1.
Yes.
So, okay.
Yes, sir. Yes, sir.
So,
Okay.
still asymmetric, no?
Yes, sir.
By definition. Okay, continue.
So let's come to anti-symmetric relation.
Okay.
So by definition, a relation R on a set A is called anti-symmetric. For example, for our set A and B, so then we have set A 1, 2, 3. Is it anti-symmetric for R1? 1, 2, 2, 2, 2, 3. So, one, two, 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 three. So this is anti-symmetric. So A is equal to B. Equal to X. It implies that n then X is equal to 1.
X is not equal to Y or Y ang X plus 2.
Yes, sir. Yes, sir. Yes, sir.
Either ang 1, 2 ang naa diha pero wala diha ang
Yes, sir. Wala ang 2-1.
tatlo.
Yes, sir.
Ya ang 2 kay dili man element sa dili man element siya, ang 2 dili man equal sa 3. So pwede nga ang 2, 3 wala. Pwede po ang 3, 2 wala sa to.
Yes, sir. Pwede ang puti, wala. Yes, sir. Ako
Isa
sa
ni? Kinsa nag-report karon si
Misa, sir, Misa.
element sa N. Ang
Yes,
Y
sir.
element sa N, pero ang XY dili na siya element sa N, that is element of N cross N. Okay?
So, element N cross N.
Okay?
Yes, sir. Yes, sir. Noted, sir.
So R3 is the set of all X, Y in N cross N. Kami, Christian. Christian.
Hello, sir. Yes, sir. Good afternoon, sir.
Okay. Give me an element of R3. Give me one element of R3.
First,
3 and 9.
first two, sir. Two,
What's
four,
that, oh?
416.
4. Is that okay? Okay.
So,
Yes, sir.
Okay, continue, Dobe.
so
Okay.
a relation may be symmetric as well as anti-symmetric at the same time. So, for this example, uh, set A 1, 2, 3, 4. Symmetric ba? So, very clear because 1, 1, we have 1, 2, 2, 1, 3. So 1, 1 and 3, 3 is symmetric and anti-symmetric. So dala. So R2. So we have for R3, example, if we have A and B map to C, then we have A map to another. If R is not transitive, there are elements A, B, and C not belong to A such that A relation or related to B and B related to C. An ordered pair B and C is an element of R, then A an unordered pair A and C is element of R for A, B, and C element in C.
Kung transitive,
Yes, sir.
kung ang A ag B element
1, 2. Yes, sir. Now may 1, 2, sir. 1, 1, then 1, 2.
okay?
Sir.
Okay, 1, 2.
Yes, sir.
Ang 1 giwa sa 2, nya ang 2 gimap sa 1, so na 1, 1. Okay. Sige.
Yes, sir.
Okay.
So for R2, so this is not transitive or one, 3, 3, 2, and 2, 1. So since 1, 3 belong to R2, then 3, 2 element in R2, but the 1, 2 is not element in
R2. Okay.
2, 3, 4, 1. So 2, 4 is element in R, then 4, 1 is element
Okay.
for that type of relations.
Yes, sir. Can you hear us, sir?
Continue.
Right,
Ganyan lang.
on partition, equivalence relation, and equivalence class quotient set.
Okay.
Professor Dr. Castillo, sir, good afternoon. Classmates, good afternoon. So let S be a non-empty set. A partition of S is a subdivision empty subsets. Precisely, a partition of S is a collection of S such that each A in S belongs to one of the AI. The second, if AI is not equal to EJ, then AI intersection EJ is not empty.
It's empty.
It's empty rather. It's empty. Yes, and 7. Consider the following collections of subsets of 9. So which of the following C1, 1, 3, and 5?
Sir Kanyeda,
Yes, sir.
again, a partition is of a set A is ito siya, is a subset, contains subsets
Yes, sir.
of A, no? Union is A.
Yes, sir.
Okay, take note of that, ha? Sige daw.
For this example here, the given S. So we notice that there is on the definition, each A in S belongs to the AI.
Okay.
So there should be a complete list of the
So, murag ang naitabuan na Sir Kanyeda, ang imong A1 is 135. Sakto?
yes, sir. A1, sir.
Ang
And
imong A2 is 26.
yes, sir.
Ang imong A3 is 489.
Yes, sir. Then
Are they mutually disjoint?
yes, they are mutually disjoint, sir. However, there is lacking, sir, in elements, which is 7. So
Okay.
therefore, it does not define the partition.
Okay, meaning ang A1 intersection A2 nimo is empty. Ang A2
Yes, sir.
intersection A3 nimo empty pod.
Yes, sir.
Ang A1 intersection A3 nimo empty pod. However, the union of A1, A2 and A3 is not A. Kay mawalan siya og 7, di ba?
Yes, sir. That's
Okay, that's why it does not define a partition.
yes, sir.
Okay.
Okay.
Continue.
In C2, for let's say 1 to 3 is considered as A1, then 2, 4, 6, 20. This is 2 and 8 is considered. So, okay, we have here an intersection which is 5 on A1 and A3. Therefore, this cannot be considered as a definition of a partition. This does not define a partition still.
Okay.
But on union, however, it can, because it has an intersection,
It is the
therefore
whole
it cannot
of
be
A.
considered a partition.
However, the A1, A2, and A3 are not mutually disjoint. Therefore, naay mga sets dito nga pagkuha nimo sa partition, okay?
Yes, sir. Then
Okay,
for
okay.
C3, in C3, so the A1, we have 1, 3, 5. For A2, we have 2, 4, 6, 8. And A3, 7, and 9. So the union is equal to the A, and it is mutually disjoint. So therefore, C3 is considered as the partition of, okay, the given S.
Okay. Sige.
Partition. Saan ka naman tinapit na? Okay, for equivalence relations. Okay, let S be a non-empty set. A relation R on S is an equivalence relation if R is reflexive, symmetric, and transitive. So again, equivalence relation, it can only be considered an equivalence relation if it is reflexive, symmetric, and transitive. So we have examples, like for example,
I will give you an example, Mr. Kanyeda, para masabtan ni mo kuan kining equivalence relation.
come again, sir.
Ang A daw related daw sa B if and only if ang 2 makadivide sa A minus B. For example, ang 3 related sa 5 because ang 2 makadivide sa 3 minus 5. Correct?
Yes, sir.
Ang 7 ang 4 related siya sa 8 because ang 2 makadivide sa 4 minus 8. That is congruence modulo 2.
Yes, sir. Yes, sir.
Okay?
Yes, sir.
That is an equivalence relation.
Yes, sir.
Sakto? Okay. It is transitive, it is symmetric, di ba? Ang A related sa A because A minus A which is equal to 0.
Oh, yes, sir.
Okay? Ang A related sa B, ang B related po sa A because if A minus A. So,
Yes, sir.
reflexive.
Quotient set. So, by definition, 4.9, let R be
Kaning
for
kanya
each
siya.
A. Yes, sir.
Sa B. Okay. Kung ang A related
Yes, sir.
sa
Yes,
B,
sir.
meaning ang 2 makadivide sa A minus B. Pero kung ang 2 makadivide sa A minus B, makadivide po siya. If A is related to
Yes,
B,
sir. Yes, sir.
niya ang related sa A C ang pasabutan na ang 2 makadivide sa A minus B. Pero kung ang 2 set of Andy, even number, pag union ni mo anak niya, Mr. Kanyeda,
Yes, sir.
ang union niya is the set of natural number. Pero ang intersection nilang duha is empty. Are you with me?
empty.
So,
Yes, yes.
partition siya. Okay, you may continue lang.
Of A in S in R. The collection of all such equivalence classes is denoted by the quotient set of S by R, the set of
Okay.
equivalence A, uh, uh, is equivalence set of A that is A in S. So it is called as the quotient set of S by R. So by theorem 4, R is A, and if A equivalent set of A, the equivalent set of A and the equivalent set of B are one equivalent set, sir. Equivalent set of or bracket ang akong nadung sir
Kanang, so, ato na lang siyang tawagong bracket 1, okay?
okay, sir.
Okay.
Okay.
A2 o A3. Mao na ang imuhang mga equivalence classes. So therefore, an equivalence classes is a set.
Okay, sir.
Those are called equivalence classes. Okay?
Okay, yes, sir. I guess this is
Ha?
modulo 2, sir. Correct ba ko, sir? Issue niya partition. Then it's modulo
Okay.
2.
Inyo.
Let S is equal to the set of 1, 2, 3, 4. Okay, 2 and 4.
Isang
Yes,
tawagon
sir.
ng bracket A where A
Yes, sir.
is an element of
Okay, sir. Okay, sir. So note that R is the equivalent. This is the example A1 is equal to the set of R in between 0 to 3. R is called the remainder and Q is the quotient. And X is in AR. So,
you you can define a relation on a certain set. If you can define a certain will turn the set into subset, no? Ang katong equivalence ka mo na ang kuha sa iyahang murag point yun ni Sir Cañeda nga kung nakay set nga makadefine ka dito og equivalence relation, ang buhaton sa equivalence relation is tunga-tungaon to niya tong imuhang set into subsets of A. For example, ang set nimo is A, na equivalence relation dito. Tunga-tungaon sa equivalence relation ang imong set into subsets. Ang tawag atong taga-isa ka subset dito is equivalence class. Okay? Ang union sa mga equivalence class disjoint. Okay? Okay, Sir Cañeda?
yes sir.
Okay, so okay. Umana?
Oh, attendance lang sir.
Okay, please.
Yes sir, yes sir. Thank you for listening.
Nag-prepare ka Cañeda og kuwan kining Sir Cañeda and Sir Mesa for their presentation. Congratulations. Nga nahuman na gyud ang inyong inyong requirements, which is a report. Then we will proceed to the group of Sir Elizalde.
Sir,
Okay.
sir.
Should we make another link or dili lang?
Murag okay naman siguro ni kang Sir Christian sir.
Okay, sige.
Okay na ba?
Okay, so should we start now or should we need a break for 10 minutes, 5 minutes, 10 minutes to prepare? I-prepare na dahil ang inyong presentation.
Yes. Everyone, especially to our professor, Dr. Giovanni R. Castillo, sir. Good afternoon. My classmates, okay, so our task with Sir Stephen Elizalde will discuss on the definition 5.1, 5.2, 5.3, and 5.4. So my part is to discuss 5.1 and 5.2. So I will be present to you my presentation. My topic is all about functions. Okay, so the topic, in my topics, it includes the definition 5.1, which is the function, the domain and range, and the definition 5.2, which is the image, the pre-image.
Domain, range,
Yes, sir.
and pre-image,
Yes, sir.
images.
And then the image, pre-image, and range. That will be my topic, sir.
Okay.
Okay, so let's have a brief introduction on function. So let x and y be sets. A function f from x to y is a relation from x to y with additional property that for each x is an element of x, there exists exactly one ordered pair component.
Okay.
Correspondence is called a function. So in other words, correspondence. Based on
No.
ma'am,
Sir,
sir,
relation needs not be one to one.
no sir, sir, yes sir, but I say a relation can
Needs not be one to one. Because nabi tay technical ba nga definition ang one to one. So
okay
avoid
sir.
using one to one ha.
Okay,
Just say just say nga a function is a relation which only allows one
one
ordered
ordered
pair
yes
such
sir,
that the first element is the same, correct?
yes
Okay.
sir. Okay, so
Okay.
so based on the definition 5.1, which is the function, so let x and y be sets. A function f from x to y is a relation from x to y with additional property that for each x is an element of x, there exists exactly one ordered pair, which is x and y, and f having x as a first component.
That's it.
So that is called a function, sir. If there is only exactly one ordered pair in the
Okay.
set
Okay.
x is called the domain. So of course, what the dom of f and the set y is called or x is a function of y. The range is a subset of the codomain containing all of those second components. So in other words, the range is also, and another term for a range is also a codomain, sir. Am I
No.
what?
No. A codomain, your domain is X.
Yes, sir.
Your
It's
codomain
range
is
or
Y. The set of all Y in Y which has an image in X is called the range. So therefore the range is just a subset of the codomain.
Okay, sir. Thank you, sir.
Okay?
So that is all about the definition 5.1. So let's have an example. Okay, look at this example. So consider the sets x is equal to 1, x is an element of 1, 2, 3, and 4, and y is an element of 1, 3, 5, 7. So we are going to define the following relation from x to y. Okay, so I have 5 example. From x is equal to an ordered pair. It has 4 ordered pair. 1, 3, 2, 1, 3, 5, and 4, 7. And for G is equal to, it has 2 ordered pair, 1, 1, and 3, 3. And for H, it has 4 ordered pair, 1, 1, 2, 3, 3, 5, and 4, 1. And for J, it has 1, 2, 3, 5 ordered pair, 1, 1, 2, 3, 3, 5, 4, 7, 2, 7. And for path, it has 5 ordered pair, 1, 1, 2, 3, 3, 5, 4, 5, and 1, 1. So these are an examples of relation. So we are going to define the following relation if this is a function. So in our example, in that 5 example, we can say that f, j, and h are functions from x to y. Am I right? While g and path are not function. So
Ibalik daw.
f and g is a answer. F and g
Kinsa ang function niya?
are function.
Let us look at it first. Kinsa ang F, is it a function?
Yes, sir. It is a function
Why?
because the domain is not repeated, and there is exactly one ordered pair in the domain.
Okay. Duha raman ang ay Sir Ratio, duha ra jud kang condition ang function. Number 1 is nahurot ang imuhang domain. Okay?
Okay.
Nagamit nimo ang 1, nagamit nimo ang 2, nagamit nimo ang 3, nagamit nimo ang 4. Are you with me?
Yes, sir.
Okay.
Sir.
Ang ikaduha, kinahanglan nga katong mga elements sa imuhang domain isa ra gyud ang pares.
Yes,
For
sir.
example, kinsay pares sa 1? 3 ra gayud, di ba?
1 and yes, sir.
3 ra ang pares sa 1. Kinsay pares sa 2?
1,
1. Kinsay pares sa 3?
5,
5. Kinsay pares sa 4?
7, sir. So
What if I will add there 1 4? Is it a function?
no, sir. It is not a function, sir, because it has already 1 in a first one.
Okay, dili pwede mag-occur ang first component kaduha.
Yes,
Are you
sir.
with me?
Yes, sir.
Okay. How about 1 3 1 3 ano no? 1 3 2 3 3 3 4 3. Is that a function?
Yes, sir. It is a function, sir, because sir, the domain there is exists only one only.
Okay.
But
For example, like 1 3 sulat ra gud 1 3 2 3 3 3 and 4 3. What is your domain?
okay, sir. Our domain, sir, is 1, 2, 3, and 4.
Okay. Hurot.
Yes,
Hurot
sir.
sakto?
Yes, sir.
Kinsay pares sa 1?
3,
Kinsay pares sa 2?
3.
Ang pares sa 3 ra jud sakto?
Yes, yes, sir.
Kinsay pares sa 4?
3, sir.
Oh, 3 ra jud. So therefore, your domain there is X and your range is 3.
Yes, sir. Yes, sir. So that is.
So therefore, ang range nimo, Sir, kinsa ni? Ratio, no?
Yes, sir.
Is just a subset of your codomain. It is not necessary hang ang range nimo maupod ang imuhang codomain ha, dili na siya necessary.
Okay, sir. Noted, sir.
Okay.
Thank you, sir, for enlightening, sir.
Are you with me?
Yes, sir. I'm listening.
Ang range nimo dili na siya necessary nga maupod na ang imong codomain. Ang range nimo that is just a subset of your codomain. Natay special term ana Mr. Ratio kung ang range nimo is equal sa imong codomain. Gitawag na to nga onto nga function. But if your function is not an onto function or surjective, your range is merely a subset of your codomain, okay?
Okay, sir.
Okay. Sige, continue.
Okay, sir. So, since there are excess values of the means or fine, it is what you said a while ago, sir.
Sige na, tanaw na nato daw. Ang G, dili. Kay ngano, unsay reason sa G?
Kaya ay sir ga ko answer na number sa domain. Which is,
Naay?
there are 2, which is 2, there are 1, 2, 3, 4, 2. So, there is a number that exists more than 1.
No. Dili ka na ang reason sa imuhang number 2 nganong dili siya function. Ang reason sa number 2 is wala na hurot ang imong domain.
Okay, sir.
Tanawa, okay sa may nagamit nimo sa imuhang domain. Sa G, di ba ang 1 raman og ang 3?
1 o 3 na, sir. So,
Abot 2 ang 4.
wala, sir, madam.
O wala. So, di mo na yung reason.
So, that is not a function, sir.
Condition 1 is violated, correct?
Yes, sir.
Di ba, ang condition 1 sa function, kinahanglan tanang elements sa imong domain na ay pares.
Yes, sir.
Ang condition 2, tanang elements sa imong domain, isa ra gyud ang pares. Okay, so, for number 2, violated ang condition 1.
Yes, sir. Okay. Yes.
How about number 3?
That is a function, sir.
Number 3 is a function 1, 2, 3, 4, 1, 3, 5, 1. Kinsay mo range diri, Mr. Ratio?
Range, sir? 1, 3, 5, 7. I know, 3, 5. No, 1, 3, 5.
1, 3, 5.
Yes, sir.
Okay, 1, 3, 5. Di ba ang range mo 1, 3, 5 lang?
Yes, sir.
And that is just a subset of Y.
Yes, sir.
So therefore, that's my point. Ang range mo subset lang na sa imong codomain. Dili na siya necessarily imong codomain. Okay?
Okay, sir.
Okay. How about number 4? What is violated there?
Number. 1, 1, 2, 3, 4. The answer, the domain.
1, 2, 3, 4. Saan na violate? Ang condition 1, condition 2?
Condition 2.
Ha?
Condition 2, sir.
1, 2, 3, 4, 2. Tanawan ng 2, 3 o 2, 7. Sakto?
Yes, 2, 3, to 7. Yes, sir.
2 is mapped to 3 and 7. So, 2 is mapped to 3 and 7. So, therefore,
That's
condition 2 is violated.
Yes, sir. Violated. So it is not a function.
Oh, this is not a function. How about number 5?
1, 2, 3, 4. Condition 2 here, sir.
Unsa?
Not a function, sir. Not a function.
Not a function, why?
1, 1.
Condition 2 again, it's violated. Look at 1, 1 and 1A. Ganun nagdubli man ng 1, 1. Pwede lang gawin mo pa ng 1, 1 din na isa?
Okay, sir. That is an example, sir, for sir, sa book ay sa online.
Lyrical na siguro na sir kay maupod na sa PDF na imong gisend.
Okay, so kuha ng 1, 1 din na ha. So 1, 2, 3, 4.
Give my
Ito?
yes, sir.
What is the range? What is the range?
The range there, sir, is 1, 3, 5, and 7.
Okay, so kuhaan siya. Function?
Functions, yes, sir. Kung waraon niyo itong isa ka-order.
Okay, sige. So that's it?
Yes, sir. That's it.
Okay, sige. Continue. Nasabta na ang function, class?
Yes sir.
Okay, nasabta na ang function. A function is a relation, ha? It is a relation. But by the way, class, instead of x, y, element of f, listen, instead of x, y, element of f, ang atong usual nga naandan is f of x is equals to y, correct?
Yes, sir.
We don't use the notation ordered pair xy is an element of f, ha, kay murag kiwa kay na sa itong mga bata. Instead of saying the ordered pair xy is an element of f, we say f of x is equal to y kung
Yes,
function
sir.
siya, okay? We are much more familiar with that notation, okay? But there is no harm if we say xy is an element of f. Okay?
Okay, sir. Okay, sir.
Okay, so let us
Thank you, sir.
continue.
Okay, so for the definition 5.2, which is the image and the pre-image and the range. So, okay, so suppose f such that x is implies to y is a function, and x is an element of x, then f of x with f of x will denote the unique element in y, which f assigns to x. These elements f of x and y is called the image of x. Under f or the value of f at x, and x is called the pre-image of f of x. We also say the set of all such image value is called the range or image of f, and it is denoted by run of f. M is equal to the set of y element of y such that there exists x elements of.
In other books, range of f is also denoted as image of f or f of x, okay?
Yes, sir.
F of big X, okay? So those are the image. Nasabta naman mo ang image, no? So kung mayroon ka og AB is an element of f, kinsa image sa A?
And quants.
F of x is equals to y, kinsa image sa x, Mr. Ratio?
And quants, sir, and y.
Y, kinsa pre-image sa y? X.
And yet assign x.
Okay, assign x, okay? Sige.
Okay, sir.
Okay, continue.
So let's have an example, sir. So example 5.2, define the following relations from R to R. Is this a real numbers or R to R only?
Ha?
This is how will I read this one, sir? Real numbers or R to
Okay. F is a function from R to R.
R? Okay, sir. So I have two examples here. So for number 1, f is equal to the set of an ordered pair xy such that x is an element of real numbers and y is equal to x squared. And number 2, g is equal to the set of an ordered pair xy such that x is an element of real numbers and x is equal to y squared. So to answer, so we are going to define the following if relation if it is a function or not, sir. So
Sige.
sa number 1, sir, the answer for number 1 is ako dra ba? I'm sorry, sir. Correct me if I'm wrong, sir. If my correct my what we call this one, my solution, if it is correct or not.
Okay.
It's just my understanding, sir. So I can say that number 1 is a function because
Okay.
this is one, sir.
In fact, that is called the
I
quadratic function. We are very familiar with that.
Yes, sir.
Okay?
And then for number 2, sir, this one, for number 2, x is equal to y squared is not a function, sir.
Why?
Because yatun about sa kuan, sir, yatun values ay sa domain, sir, na
For example, ang kuan ano Mr. Racho, ang x nimo, asa nimo i-assign ang imong x?
Sir?
Ang x nimo, asa nimo i-assign?
Sa f of x.
So y yung negative y. For example, tawag ko ng number 2 nimo.
Okay, sir.
Tawag number 3 to. The set of all x in R such that x is equals to y squared. So what is the value of your y?
X.
Plus minus x.
Plus.
Take the square root both sides.
Okay, sir.
Diba plus minus is square root of x?
Yes, sir. Plus minus square. Yes, sir. Plus minus square root of x.
Okay, for example, what is the value of if your x is